for this, we want to be able to transform absolute value functions. What that means is change kind of how it looks. And there's a couple, there's really just a few different things that we need to keep in mind. So if we have, and we're just going to use our basic, we're just going to start our basic f of x is equal to the absolute value of x. That's our starting function. That's the basic absolute value function. And hopefully you remember this from the last video that you watched over and over and over again because you liked it so much. And it looks something like that. Our axis of symmetry is the y-axis, and it reflects, even though that graph doesn't quite look like it reflects, but it makes kind of a V. Starting at 0, 0, it makes a V because our negative values become positive. When we say transform, what we're talking about is making it so that we move this V to the left or to the right, up or down. We change how steep our arrows move. And so I'm just going to go over all of those really quick, and then in Desmos I'm going to show you what it looks like because they graph better than I do. So we're starting with f of x equals absolute value of x. So if we want to flip this set of arrows so that it is facing down, so something more like this, then our f of x would equal negative absolute value of x. And what we say is that there's a constant on the outside, usually they call that an a, and if our a is negative, it's going to flip it upside down. But what we're really doing is whatever the positive, whatever our absolute value would be, it's now a negative. So it wouldn't matter if it was positive, it would be negative, and if it's negative, it's going to be negative still. Okay. If we have something like this, f of x equals, and we'll go back to our positive x, and we just add some number b, remember that's from our y-intercept, then our graph will look something like this. And that point right there is b. Okay? If we were, and again, and so that's adding a b. If we subtracted a b, we would move it down here. If it's positive, it's still going to be going up. If it were negative, then it would be going down. If we do this instead, and this one's a little, sorry, I didn't want that plus b on there. This one's a little bit less intuitive. Usually when we see so if we see a positive, we move it up, right? If we see a negative or a minus, then we move it down. It's a little bit different in this case because when we're changing that x inside of the absolute value, and you could plug some values in and see that this is true. It's a minus, but it's actually going to shift it to the right that many units. So right here would be n, and our graph would look like this. Okay, so if it's minus, it moves it to the right. If it's plus, it's going to move it to the left. And that's if it's on the inside with that. Okay, and then we could also add a b here or subtract a b, and that would move it up and down as well. So we could move it down or up. Okay. If we put a different value of a, so if we did something like 1/2 of the absolute value of x, this is still our slope. It's still a rise of 1 and a run of 2, and so our slope is going to look, it's going to come out. Like we rise 1, we go over 2, we rise 1, go over 2. So it's going to come out, and it's going to be less steep. It's going to look more like, well, those arrows should be at the same angle, but it would look more like this. Okay, and so just really quick in Desmos, I'm going to go through and just do some of these so you can see what the different transformations look like. Okay, so there's our original absolute value of x, and you are free to play around with Desmos and use it. Okay, so the first thing we did is we did, oops, lost my x. We did a negative absolute value. Okay, so you see that flips it right back down. And then I'm just going to use this same graph, and you can see how it reflects to, or how it relates to the original. Okay, so currently negative x would look like that. If we change that so it's not negative, but we move it, let's do down 3. Okay, so minus 3, look, our y-intercept is 3 on our axis of symmetry. Kind of looks like a chevron. Let's keep it down there at negative 3. We can flip it upside down if we put a negative right there. If we want to move it to the right, we put a minus, and let's just do 2. So you see how that moved it to the right, so that our x value is 2 over to the right. And if you're having a hard time understanding why that shifts it to the right and not to the left, I understand. I struggled with that for quite a while, actually. Just plug some numbers in to see what happens. So x minus 2, so let's take this off for a second. So if we put, if we want 0, right, here is 0, right? If we plug into our equation a 2 minus 2 is 0. So that's when it's going to be at 0. If we do a plus 2, and we're looking for where it's going to meet 0, then negative 2 plus 2 would be 0. Okay, so that's why it shifts the opposite way of what you might think, is because we're looking for where the graph becomes 0 on the y-axis, and for it to cancel out, it has to be the opposite. I hope that was somewhat helpful. Okay, and then what if we multiply this by a half? See how it widens it out, because our slope is now 1 over 2 instead of just 1. Or if we were to make the slope steeper, like a 3, it brings in the two ends and we get a steeper slope. And that's really all you need to know for transformations, and that it applies to absolute value functions, but it actually applies to other functions as well. Where you put if you're subtracting the x multiplied by the slope or adding to the y-intercept, it'll move it up or down. The same rules are going to apply, okay? And then the negative would flip it. Most graphs, because they're not absolute value, it's not going to make the v flip upside down. It'll just reverse your slope. So instead of being a nice negative, it would be a puff puff positive, or instead of a puff puff positive, it would be a nice negative. Okay. Hopefully that helps. Yeah, hopefully this video is one that maybe you might want to watch it a couple of times and get this all in your notes so you have a good idea of how to do it.